The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration podcast. The Sporlan S3C series of case control products provides safety, security, and service for remote and self-contained refrigerated display appliances. The S3C family of controls includes a case controller, display module, and a valve module that all support open protocol communication via BACnet and Modbus. The peer-to-peer system is capable of standalone or coordinated control of up to 8 refrigerated cases per lineup. Using this family of controls simplifies and shortens the time required to set up new equipment or retrofit an existing system. Ask your local refrigeration wholesaler about the Sporlan S3C series. Parker Sporlan, leading the charge.
Not a fan.
Yeah, I know. I just gotta do it. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast, and here are the hosts, Brett Wetzel and Kevin Compass. What's going on, Kev? How was your excursion?
Oh, not fun. And I drove basically every state in the Great Lakes, from Grand Rapids, Michigan, to Indiana, to Ohio, to Kentucky, to back to Illinois, to the Wisconsin, Indiana, or Illinois border. It's all over the place in the last 3 days, trying to close out a bunch of jobs and look at a bunch of other jobs.
Cool.
It's just like chaos season.
I was unemployed for the weekend.
No, shut up.
Just for the weekend. Just till Monday. And then Tuesday I started my
So
job.
is the first 2 days you've been forced to take off in 20 years?
That's what they said. They were like, hey, I was like, well, I'll see you guys Monday. And they're like, no, you don't start to the first. I'm like, what am I going to do? Is take a day off? I'm like, all right. So got my new business cards and ready to roll.
I don't have business cards.
Look, it looks pretty. Bam.
I don't even exist. I'm just here.
So
wow. It's a director of strategical and technical services. Should just say I'm Brett.
You're such
yeah. Should just say I'm Brett on there.
You're such
that's what I would have put. It would have been so much better. Such a better conversation starter.
What's my title? Just Brett.
Who the fuck is Brett?
I'm gonna do that now. I'm gonna run through ChatGPT and just see what refrigeration analogy I can pull from my initials. I used to
should have put should have that solution. You should have put mentor on there.
You're such a dick. I was so when I went to school for engineering, I would call myself an ass. When I started getting energy management, they're like an ass. I'm like, yeah, automation system specialist. That's clever. So what are we talking about? We didn't even talk about it. Normally we spend 15, 20 minutes discussing what the hell we're going to talk about today. I want to actually, what I want to hear is your newest electrician excursion, and then we can figure out what we're doing from there.
Oh, I just got absolutely dicked by the electricians on 2 rooftops. Like, it's the last thing I had to do in this controls job besides fix a background. And I'm like, okay, I'll go there. Let's pull these 2 discharge air temp sensor wires down. Mm-hmm. And put the zone temp sensors in. These AON units, they come with 2 discharge air sensors, one for microthermal, one for the AON unit. It doesn't matter if it's CES and CPC stuff. There's always two sensors, one for the EMS and one for the unit controller if it has it. It's very important how you mount these, but you also get dicked every time because AON supplies them in like the thickest wire I've ever seen. It's 22 gauge wire, but it's thick as fuck.
Is it like the Novar com wire, like that big blue jacketed wire?
Yeah. Yes, and it's split in 2. So 2 of them. So it's literally like pulling 2 18-4s down through it. These jagoffs pulled the wire out of the unit and put a seal tight 90 at the bottom of the curb where it went in. So I couldn't get anything through it. I spent 3 hours pulling 2 wires through.
So what are they using? Is it 3/4 that they're doing, or 1 inch?
They pulled 3/4 here, and 3/4 is pretty tight, but it's doable. But 1 inch is definitely easier. At a new store, 3/4 perfect. Because you generally got a 4-wire and 2 wires coming up. But I usually cut the Aeon unit wires off, slice them off, and I just run 2 22/2s down there. Because fuck that. It's ridiculous. And it looks like shit when you're like trying to trim it out. These random purple wires going down when everything else is white. Plus, it sticks out in the ceiling, white ceiling, and you get 2 random purple wires coming down. It's very visible. So
you said you had go ahead. We're lagging a little bit.
I had to cut the old comm lines that went up to the old unit and use those. That was an adventure. And then, of course, Aeon fashion, there was a massive amount of stuff wired wrong. So just dehumidification wired wrong, random reheat valves wired wrong. So it's any my responsibility, but I know if I don't fix it, it's going to be my responsibility.
So first off, you had to use more lube than at P. Diddy's house. And then the second thing is you had to, what kind of units, what kind of controllers are they using? Are they using microthermal? Are they using, okay.
Microthermal. And then there's some of the Aeon controls in there. So I think it's Microtech or whatever the hell they call it, or Omni or whatever Aeon calls it. So there's some of those in there for the reheat controllers. Like they're wired into the actual microthermal boards. So they're sending it a 0 to 10 signal and it's doing the reheat off that. There's some Aeon stuff in there. And then obviously the Aeon heat boards that just fail randomly, except now they have no covers on them. So maybe they won't overheat as much.
So one of my friends, Matt Waxer, goes out to, I think it's called the hell's it called? They call it the tunnel, the cave. Oh, the cave, where they do a lot of the control stuff and a lot of the training out for Aeon. I think it's out in Kansas City. He invited me. He tried to get me out there, and I was too busy to go out there because I thought that'd be pretty cool to go out to the Aeon facility and scope out the cave. But I've never been there.
I will admit they make the best rooftops. It's just they consistently do the same things wrong, which it's easier if you already know what it is. So to go through it, but they do have the best dehumidification strategies out of anybody I see. And I would much rather have them in Aeon than a Train or something else. Train's awful. You can't even get information from them anymore.
You got to know someone that's in the special club in order to get anything out of them, which sucks because it just makes it harder for us as technicians to actually fix anything. Like
Carrier, Aeon, all of them, it's easy to get information online. Dude, Train is they just make it difficult. Even getting a wiring diagram that's gone, it's impossible. You got to be a Train dealer or you got to go through the local branch now. It's holy cow. It's more a wiring diagram of some unit that you sold.
Why? Why make it so difficult to get it? You know what I mean?
It's ridiculous, but
no, I was just gonna say I'm gonna shut off mine. I'm gonna shut off my camera, but I'm pretty sure that it's yours because yours was doing the same thing last time until you shut your shit down. I don't know. Every so often, I got to shut off my router, but I actually have good speed now, so I don't know what the deal is. Is it better now?
Oh yeah.
Oh, son of a bitch. Okay. I don't know. They said they fixed it. No, there's only one. It's only him right now. He doesn't have his plethora of little friends over here. Usually he's got a posse over here just hanging out. Yeah. No, but what's up?
So what'd you do?
I didn't do anything. All I did was just shut off my camera.
No, it's working now. Go ahead.
No, I was going to say I didn't. So I've been waiting for the schematic from Dale Sizemore for a minute to look at this Kaiser unit, and I had to actually invest in a CAD program to look at it, but everything's pretty colored, so I had to either buy one, or actually I have a trial for another one, so I was able to convert all the schematics over to to an actual regular platform. If you want to, do you want to take a look at those and break them down, or unless you got something else going in there?
No, go ahead.
Yeah, I'm gonna bring it up right now.
It's gonna be hard to bring it up when the screen is.
Stop it. This is from your other brother, Target. He said to me the other day, he's like, "Why does Texas take all the names of like everywhere else?" I'm like, "What do you mean?" He's like, "I was in Portland, Texas, and now I'm in Jacksonville, Texas." So I don't know, because it's so big, you just don't have the room for stuff. Let's see. Let's see if this actually works now. We're just gonna have to look at them piece by piece. Percent. Share. This is the one thing I do like about the Kaiser schematics, is that just like the zero zone ones, they actually give you a little bit of a legend here that actually tells you what the hell's going on. Have you started up a bunch of Kaiser stuff in the recently, or no? You've been just working on what racks?
I haven't seen anything Kaiser in a while, to be honest to you. Like everything I've been doing is zero zone or Carnot.
Gotcha. Target's been doing some stuff. Oh my goodness, what's the other one? Kroger's doing some Kaiser stuff, and I think either Sam's Club or Walmart's doing some stuff as well. Let me bring up the other schematic because it's one page at a time. So if anyone's never seen these before, which they should have, you can tell obviously this is your multiflex board, and it's giving you your digital outputs or your relay outputs here, your universal inputs. Gives you the actual pressure transducer that should be, tells you what all the specific inputs are, what compressor safety. See, I haven't looked at the actual control schematic for the rest of it, but usually like on some racks, they'll have maybe a high pressure switch and a low pressure switch and an oil safety switch that goes to individual inputs. But it looks like in this instance, it all just goes to a master relay. You got your hot gas dump, liquid injection on the second board, Gutner water valve, and oil separator dump valve, oil supply temperature. I wonder if that's actually coming off the separator. That'd be really convenient if it was, because then you can actually monitor it and actually see if it's actually working correctly. Ambient temp, pre-cool temp, suction line temp. Let's see what else we got. Gas cooler out, flash tank, gas cooler bypass. Let me bring up the next one. Maybe you can help me figure out what the hell this is. I couldn't tell what this was. So you got, Kevin, look, you got your control power coming on, breaker. So this is going to control panel, exhaust fan relay. What the hell is this? Is that what I think it is? Is it just an outlet? Okay, I just never seen one drawn like that. And then this is just for the light for the inside the cabinet, probably, right?
Did you just ask me what an outlet look?
Stop it! I did, because it just looks funny. Couldn't tell what it was. Phase loss. So there's your 120 line, 605. So usually one of these goes to the whole control circuit, and the other set usually goes to a set of inputs, but we'd have to scroll down and see where the hell they go. Circuit breakers. And then those are your current sensing relays, probably for your proofing. And it's nice because it actually tells you what input it's actually going to, if it's wired right. Same thing, other compressor. Let's see what we got here. Box cooling fan. Transformer. This goes to the low level switches. So these are going to the Cure ones. You can see it actually has the INT 267 here. Coming down this line, let's see, this is going to a relay. Liquid injection solenoid valve. This one right here. What's ODR?
Are those all going to SCRs?
What's that? Where?
I said, are those all going to SCRs?
SCR.
Yeah, for their solenoids. Are they all they AC or DC?
AC. I just don't know what this is. What would ODR be? ODR. O'Reilly's. OLC. It's not there. What the hell would ODR mean?
Outlet. Damn.
Oh, dump relay?
Regulator.
I mean, I believe this is CO2.
Outlet dump regulator.
Oh, maybe. Oh, so that would make sense. So if you have your liquid injection, then your hot gas dump. And then, oh, no, never mind. No. Because over here, you have an ODR relay, which then powers your oil dump solenoid and your gas dump solenoid.
Yeah, but those are DC. So see? So that's probably an SCR. Solid state relay.
Gotcha. Okay.
Yep. Because
so then this is power.
That's they had to have, because that's what we have. That's what we had with the early Kaiser racks, is we kept burning out the CPC or the Copeland relays on the multiplex boards because they were DC powered, and they weren't. Same the reason or issue Hill has with theirs. They burn up those little mini card relays like nonstop.
Mm-hmm.
Because they can't handle the cycles with DC power, because DC power is so much more destructive on relays and contacts so that you need S to make them last.
Okay, so this is going to the relay output board, which is cycling these, which doesn't really make sense, because then no, it does. Never mind, because you can only have, what's weird is because you can only, it's the Copeland relays on the board only have, it's not a solid state relay. So it only has X amount of thousands of cycles that it does before it doesn't want to do its thing anymore. And that's the
you
whole
sure
reason
about
why.
that? I've seen some compressors with 500-600 cycles a day for years.
You do have a point. So then this right here, I'm assuming that these are all the switches on the doors is what I'm thinking. Yeah, the E switch, fusing, select fuses, like those little switches with the lights on there. It's this low pressure cutout, medium temp. So this is like almost like a switchback relay, right? So if this goes out, it'll cut out all the compressors and then bring them all on. I don't know if they're timed or whatever, but I'll have to look. And then,
which is pointless if the oil separator can't drain.
It's very true. Very true. 4 PT relay for what is that? UDV?
I'm assuming it's some kind of staging relay. It's double
4-pole double throw. Yeah, that kind of makes sense. I don't know. It's probably on the next. On the next one. Right?
To brush you up on those basic electrical.
Stop it. I actually, to be honest with you, I've only worked on probably 8 Kaiser racks. I don't really work on Kaiser all that much.
We really didn't see Kaiser at all till a couple years ago.
Yeah. I was just talking to Dale the other day. Their manufacturing's full tilt, doing as much as humanly possible, trying to get as many CO2.
Everybody's is.
That's why you have so many European manufacturers rolling out now, right?
Yeah, maybe not now. All the ports are closed.
Oh, did they go on strike?
Uh-huh.
I didn't know. I wasn't watching the news today. I don't know if they actually went on strike 2 days ago. See, you're still lagging.
So these compressor diagrams, I will turn my fan off, or I will turn my camera off. Those compressor diagrams look fairly decent. It reminds me of the old Super Plus diagram.
Yes, I do. So this must, oh, there's that WD relay. So it's going to switch it. I'm trying to think. So normally it goes through the time. Okay, so there's the time delay. So if that WD relay switches, it's going to switch it that it's going to turn on via the time delay.
Yeah, which is, I don't know. Unless you're locking the oil solenoid on at that point, you're pretty much, I think switchback with CO2 is pretty much useless.
So it's only, I don't understand why they do it, because once you hit low pressure, that's if just the board for the compressors loses power, and damn well your pressure is going to be all out of whack, because at that point you're going to probably bypass your VFD, right? You're just bringing it on and off, on and off. What I didn't,
at least it would run. It would run really shitty, but like it would run if the controller died. But without having the oil solenoid bypassed on at the same time and constantly draining oil, you're going to run out of oil in a matter of an hour.
Yeah. There's that other relay, that OPR, and then going up through, goes through the SEB. I didn't look what kind of compressors, but I'm assuming it's something with the sling style oil system. And then you have your OMC for filling, your high pressure switch going up through, going out to the compressor contactor relay, and then out through here. Oh, so here's the OPR. Isn't the OPR was the alarm relay, wasn't it? Yes.
Yeah, I think so. So you get the. I'm not a big fan of the generalized alarm relays like that. I think it makes it harder for especially greener guys, giving them a shot. But it also forces them to use a meter. But what I don't like is everybody just goes and hits the reset button, and if it's like the compressor module, it's going to go into alarm and reset, or the OMC. Doesn't even look like they're using the OMC alarm.
You don't even know. You don't even know. OMC relay, set of contacts. It would probably send the voltage back up yonder.
Yeah. Which 12 is the alarm. So makes sense.
Then once again, so I've had a guy, there was a guy that was working on a rack, and he was freaking out because it says the general relay, but it said oil fail within the actual schematic. So he's like, keep pressing the oil fail switch and nothing's happening. I walk up, like I had to drive down there, and it was one of the Danfoss resettable head pressure switches that if the top breaks off, it's just got to stick a screwdriver in there to get it to reset. I did that. The compressor came on. He started punching things. He was angry.
Exactly why, like, I'm on people about meters. Don't just be grabbing resets. Get your meter and see what it's actually tripped on. Because we've had a rash of Bitzers lately that have had faulty modules that they're tripping like 60 degrees lower than they should.
Really?
And yeah, it's been multiple times where guys have not been able to figure it out, and it's been that. And they keep thinking it's because it's just labeled oil. They need to relabel this as like general compressor alarm, and stop calling it the oil fail.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales at westermeyer.com. That's WESTERMEYERIN.com.
That's the OPR. You know, it would be nice if they had everything on here. Oh, wait, oil pressure alarm relay, and then oil pressure control. So oil pressure alarm relay. So that's what that one is. And OPR. So that's going to turn on for an oil pressure, but I still don't, I don't get what that other ODR was. I don't know if that was the general, maybe a generalized one. CPR. Nope, it was down here. ODR. You'd have to, okay, so let's see what 3.7 was. So if we go back to here, for 3 oil separator dump. Okay, that's what that is. Never mind. So that's not an actual alarm relay. The only alarm relay they have on here is this one, the oil pressure relay. So I don't know if it generally goes to a different input, and the only way to actually see that would be to go back to this. So you have the proof. Okay, so they have one for each one. So that just probably tells you if you have it's one of the generalized ones, because it's still going to go off if the compressor goes in high pressure. No, because it's gonna kill.
Yeah, no,
it won't, because it's just going to kill the power going to there. The only way that you could do that, you'd have to won't know it's on high pressure. Yeah, you'd have to have a 3-pole high pressure safety switch.
Which, like those Emerson / Copeland high pressure switches, like the self-contained ones.
Oh yeah, they're made by, they say Alco on them or something?
I think they're still Alco, maybe. I don't know if they say Copeland now. I haven't seen one in a while.
Yeah, don't ever try to adjust those either. They're factory set.
You could adjust them.
You can, but usually they put some. Yeah. The one with the
especially the low pressure switches. I generally have to adjust them every single time.
So that's the other compressors.
And it's like a 0.0005 Allen key, and it's like the smallest one. That is the one you always lose.
The one they use for thermostats, for the thermostats that are on office walls and shit. All right, so then here you have your. That's right, you don't work on HVAC at all.
It's not true. I made the hotel room air conditioner come on Edger. It was one of those locked out energy management ones where it shuts the fan off. And I got really pissed off on Tuesday night and went down to my truck and got a control screwdriver, took the thermostat apart, and realized that you could there's override buttons inside the thermostat. So if you're in a hotel and it's got one of these Vermo stats and you want the fan to stay on, it's pretty simple. You just take the top screw out, pop it off, and push the energy button 3 times, and it locks the fan on. I was fucking livid.
It's amazing. So this is the power supply for the iPro, the XCV control, and the other iPro. This is also your Danfoss CTR dryer. I think they're using these. This is the one where it's the bypass for the gas cooler, I think. Have you seen that implemented yet?
Well, I have, but they're using EKE superheat controllers too, or KW is to drive the high pressure valve. They aren't using the XEV or the EXV. They aren't using those from the Dixels. They're using the 0 to 10 volt signal and that standalone Danfoss controller, which we've had pretty good luck with that standalone Danfoss controller. The only problem is it's one more component in there that could fail or need to get done. And we've had several instances where the screen doesn't get shipped out with the rack and you can't start without the screen because you can't program it.
Those are you, in order for it to communicate with it, you have to, it's like any other case controller, you have to set the address, no?
You have to, no, there's no address because you're giving it a 0 to 10, but you got to tell what size valve and how many steps, and what you have to enable the software switch. So you need the screen to do all that. So one thing to really watch out for though is making sure that Danfoss controller and the iPro and have the phasing correct for the transformer. Make sure the common is actually the common and the hot is actually the hot, because if you flip that around and that 0 to 10 goes to that Danfoss controller and you got the common and the hot flipped in the transformer, you're going to smoke the iPro.
Oh, you're talking about on these itself, because I see, because then you're putting the common where it doesn't belong and so on and so forth.
Correct, because that Danfoss controller will light up if you flip it. It'll function if you flip the common and hot of the transformer. Okay, but when you go to put the 0 to 10 volt signal from the iPro it's flipped the other way. So
Do you remember?
smokety smoke on one of them.
Do you remember working on the Hoffman condenser fan motor controllers for the Seasons 4? You ever work on them?
Not a really long time.
Okay. It was probably about 4 years ago. And so there's a schematic that comes with the unit, right? And then there's the schematic that's on the unit. And so I forget who it was, but they basically replaced the controller twice. And I went there. I was like, dumb kids. I'm going to go out there and I'm replace it. I wired it verbatim what the schematic showed in the actual document. And it let the smoke out like instantly. I'm like, wow, I feel dumb now. So I called the guy up. I was like, listen, this is the third controller that we've done like this. What the hell's wrong with your schematic? I followed this to the letter. And he's like, wait a minute. Is this on a Seasons 4? I said, yeah. He's like, there's a different schematic on the door. I'm like, okay. So it was exactly what you're describing. It showed that the signal from the analog output where that was going to the next board over had to be swapped for that very reason because of the way that they hooked up the power. And so in essence, it switched the high side of whatever the 0 to 10 was and then ended up smoking the hell out of that board. So same exact thing that you're talking about.
Same thing happens on the protocols with the IDCMs and the transform or the multiplex board that feeds the IDCMs. They smoke the board all the time because somebody will flip the power on the IDCM or pull the wires off the power cycle or change it and won't pay attention. And if you flip the phasing of a transformer on the IDCM, the common of C2 and the common of the 24 volt input are bonded on the back of the board. And then the same thing on a multiplex board, the common of the analog output signal and the common of the transformer input and all the board signal inputs are all bonded together.
I really want to take this apart.
So if you have a voltage difference, then there goes the smoke.
Damn. You put a warning label on there somewhere. Without taking it apart, you wouldn't even know. So here's one of your favorite things, right? You want to discuss?
Oh my god, the valve wiring. Yeah, it's
I can bring up the picture the other kid did. You want me to bring that up?
Which one is that? The one you showed me this morning?
Yeah.
I thought you made that.
No.
Or did you send him my list?
No, I did because I talked to you. Remember, I talked to you yesterday, and you're like, "Who needs it?" And I said, "Your brother."
Share my list.
What?
Share my list. We need to finish it and make it.
Well, I know that. I'm waiting for you to get me all the pictures of the board so we can do that.
Yeah.
What do you mean? Yeah. Mr. Microthermal over there. I'm still waiting. I want the boards. They
aren't in the new ones.
What?
They're not. None of them are there. Yeah, on the last couple updates, it wiped all that shit.
That's lame.
Yeah.
Let me just download.
So
going.
No, but like the valve driver wiring has been a issue at every single. It's been an issue at every single site. The valve, whether you're using Danfoss or you're using Copeland or you're using Sporlan, nobody has this written out for what you're using, whether it's a 326A. We've been starting to work on this and we're getting there. And I've been compiling this as I've been doing startups and figuring out like valve no closey, valve open, but valve no closey with Copeland, or valve doesn't work with microthermal, like what has to get changed on it. And then it's been a mix of Danfoss and a mix of, we only have Sporlan on a couple sites, but Sporlan's pretty easy because it's the same thing every time. With microthermal, Sporlan's a direct go. With CPC or Copeland, it's pretty close to what it normally would be. So we've been working on this for a little while, and we're getting ready to do the flash gas bypass valves too. So this is a glimpse of what somebody else made that with some of the information that I had. Yeah, this is where it gets confusing. Because if you look at the Copeland manual for the iPro, they list the EXV or EXD driver in there. And then not the XEV20. The XEV20 is what's coming out and everything new. The XEV20 is what you're going to be seeing in all the new racks. The EXD driver is old. If you're looking at that Copeland documentation, make sure you pay attention because it'll show you the way to wire it, and it's backwards.
Yeah, he sent me this, and one of the guys from Corral had sent me how to actually hook up there, and I think I sent you these pictures as well. Basically, how to hook up the it's an intrusive thought. How to hook up the case controllers, or sorry, the expansion valves on the Corral, so you can actually utilize that for like the SMA 12, right? So this is the picture. Oh, of course, it's like small as hell, but you can see. So they have the yellow, if you can see it. Otherwise, if I make it bigger, Kevin's going to complain that it looks like a potato. But basically, you have what?
I said, damn, Jamie, fucking really shit in the bed today.
Oh, stop it. So anyway, so the black is going to the yellow, the green is going to the green, the brown's going to the red, and the white's going to the white. So it'll actually, you can run the beacon expansion valves. This will be helpful too when you start working on the carrier stuff, right? Because they're using Corel controlled ejectors for basically using it as a HPV. So if you do have a problem with, you suspect the driver or whatever, you can hook it up to the SMA 12 and just run it.
We'll see. Next week, I'm supposed to start the carrier rack. Allegedly.
Allegedly?
Yeah, it's not looking good.
Yeah.
Still doesn't have power.
Weird. Since we're talking about valve, let's just go back to the schematic, and like I said, we can keep working on this, and then we'll talk about the other stuff. So the last part of the schematic, I think. I don't know what this one is. That's lame stuff. It's fine. Oh, see, now the kids are coming over the house. Oh, this is just the cables for the Gutner stuff. Because there's a certain customer that basically what they'll do is,
The Gutner wiring diagrams where they tie in could definitely use some improvement.
So you have so they're just showing you here what's hooked up to the rack. So you have your gas cooler, speed reference, blah, blah, blah. But then on a certain store, a Bullseye store, what they do is they typically put solenoids with underneath where the water supply is. If God forbid it gets too cold, they just basically shut down the water supply and then drain whatever's in the line so we don't have a freezy pop.
Sam's and Walmart are doing the same thing. They're doing a block and bleed. So is Costco. We do a block and bleed at the other stores too. I will say this, if you're going to do that, please make sure that vacuum brakes get installed somewhere.
Yeah.
Or it doesn't work.
Vacuum brake. Oh,
it doesn't bleed. It never bleeds.
To basically alleviate the pressure off the line.
Yeah, because if it doesn't, the water line will still freeze because the water will sit in there and never drain out completely.
Yeah. So one of the other things I do want to talk about with you, because I've been looking into a lot of stuff recently as far as trying to understand more of the parameters for the iPro controller and the Danfoss 326 and stuff like that. How was I doing? They have a closure. It's almost like a closure speed, but it's not called closure speed. Let me find that up. You know anything about this? Basically the valve will close a little bit more at a higher percentage. No? Yes? Maybe?
Yeah, we have had some issues with the Danfoss valves on the Copeland drivers where I've had to turn up the phase current to get them the holding current to get them to drive properly. And it's been like 7 or 8 stores we've had that at. And I've had pretty good luck with turning it up. Turning up the milliamps a little bit more than what Zero Zone will say it's 10 milliamps. I may go to 15 or 20, and we get some better luck with it. The valves seem to be holding up and not be issues, and it's in range with what Danfoss says. So Danfoss claims it to be higher.
Someone to explain that, because I've tried looking into that, and the only thing I can come up with, so I know sometimes they have to do it when the wire run is really farther out, but from what I was doing, the reading I was doing, it was basically saying it was for if it's fighting something to close off because you just have a high pressure difference, it's going to take a little bit more oomph to get that valve closed. There is
which is what we were having issues with. When it was transcritical, we were having issues with it. If say if the rack went to go shut down, it was struggling to close when it was say like they had a high pressure situation and they need to shut off and like the compressor's tripped and they need to shut rapidly. It was having trouble then closing.
And that's what I was getting. That's what I came up with, because I never understood. Like the first time I've ever heard someone say, "Oh, you got to increase the holding current," it was that cat that used to work for CoreLink. We were having some valves that weren't closing properly, and so he's yeah, increase the holding current. But I didn't know, like, never knew really what that was and what that was actually physically doing. It wasn't until I started looking in and reading some stuff about that holding current, I had no freaking idea.
The bad thing is not every manufacturer puts their recommended holding current on their valve literature, which is very frustrating because they want you to use their valve driver most of the time, which already has the holding current programmed into it.
Yeah, so you'd have to know what type of valve it is, what capability the holding current is allotted to actually go up to, right?
Yeah, the Danfoss and Copeland ones are in there. The high pressure valve drive or high pressure and flash gas valve from Sporlan both have in there. Some of the other stuff I don't know about Corel, but like some of the stuff you got to do some hunting around for in some Googling to figure it out. So I mean, as me and Brett work on this sheet more and compile some different manufacturer specs, we're gonna put it in there and make it available for everybody. So it's a quick startup sheet because like this is happening on every job I go to. I find the high pressure valve wired wrong.
And it takes you what? It takes you what, hours to do the research, right? Unless like what you did, you basically made it easy for everybody. You wrote down every single fucking valve that you have there to make it easier for everybody. You know,
As we were doing, go ahead.
Go ahead. No, I was going to ask you if are we you want me something up where like we actually have the board so it actually shows you how it's wired out.
Yeah, we could do that. The word's enough is enough. People could figure out the quick look at it. And the other thing is like the steps, because of like the Copeland stuff, some stuff's times 10, some stuff's not. So that's super confusing. Same thing with Danfoss. Like some certain things are in times 10 increments, certain things are in Celsius or bar, and certain things aren't. So there's a lot of that to watch out for. But I think out of the last 10 startups I've done, the high pressure valve's been wired right once.
Really?
And it sometimes it'll close and it won't open. Sometimes it'll open and won't close because you got to remember, if one wire's out of place, it'll still step in one direction.
True.
So that's where it'll get you. And then randomly it may like not open all the way. Like you may hit a spot where it loses it. That's why like making sure these are wired properly and set up properly is like crucial.
Even as easy just making sure that the wiring is sound. There's no loose connections, because I've also seen that where someone makes the assumption, oh, we need more holding current, when really all it is just a shitty connection somewhere, right? Where it's just they're trying to increase it just because of a connection that's faulty.
The other thing I've been doing is taking dielectric grease and shoving it in the connectors because we've been having moisture get in there.
What are you using on the connectors?
Dielectric grease.
No, like what kind of connectors? Sorry.
Oh, terminal blocks, or if I'm doing it, or either gel caps or solder and heat shrink.
Gotcha. I can't find this now. I was looking at it and I was reading it and I was like, oh, okay. So there's a setting in here somewhere where it basically tells you like how fast of a percentage that it's going to close.
It's like close reaction speed or something like that.
Yeah.
I make it as fast as possible.
I think it's either set for 3 or 5% or whatever the hell it is, but
yeah, it speeds it up during close if there's an emergency shutdown.
Yeah, that would help so it doesn't just dump a whole bunch of hot gas directly into the flash tank. So we got something planned for the following week, but what I would like to do is do an analysis on the three, because a lot of the settings in the 326 are the same as the pack controller. So what I'd like to do is just compare the two. Maybe go through go through some orientation on these settings are going to do this, these settings are going to do this, and unless you have something else. I'd also like to go back and do some more basic rack shit.
That's fine. And then we're going to go over the XM controllers and some dirty little secrets with those.
Oh yeah, we're supposed to have. I think we're gonna have some guests from there soon. So we'll have to talk about that then.
All right.
So
All right, guys. Thanks for listening.
Yep. See you guys later.